Welcome to Summit. Welcome to the data streaming presentation. And it's less about the presentation. So I will be probably talking pretty quick, and we'll go through the slides a little bit faster. It's a chalk talk. So it's more technical. If you have your use cases, if you have your questions, you prepared for this session, and you want to discuss something, just raise your hands, stop me, and let's jump to the details, to the technical details. I'm a senior data architect for the streaming services with the professional services. I'm a consultant. I work with the customers. I work on the implementation of the solutions, building solutions, working with customers, providing the best practices, and the doing everything that is around the streaming services. On this presentation, I will define the scope. We will take a look on a couple of slides. We will define the scope of the services. I will explain them in the high level. And after that, I will start interacting with you. If you are ready with your use cases, we will just discuss them. Maybe if we need, we can whiteboard them. And it will be your time. All right. So we have real-time streaming and the real-time data analysis, and these are two different things. They usually come together, and we will be covering the services that AWS provides actually to manage that, to make it easier for us to build the solutions around that. And the first, why do we do that, right? So the question, what is the real-time analytics, what is the data streaming? I remember 12 years ago, 10 years ago, when we started talking about the big data, it was a buzzword, right? Like, oh, big data. We were coming and saying, telling to our customers, give us your data. We can extract some value from it. Give us your logs. Give us your years of data. We can analyze. We can try to do that because now we have a big data. We have Hadoop. We have clusters. Distributed system can help us to process that faster, not a single process, and we can do that. And one of the things was a clickstream. It was for me, it was the first POC that we did using the Hadoop systems, and it was successful. And we started doing the analytics, but it wasn't real-time analytics. It was the batch analytics. It was the data that was collected days, months, years, and it was fun. And after that, the customer started wanting more. Let's do more. Let's do faster. I don't want to collect the data. I mean, I want to collect the data, but I also want to do, in addition to that, I want to start processing and understanding the behavior. I want to improve my user experience, UX. And by improving that, I can actually track the UI, right? On the websites, on the how many times we are clicking, how many times we're doing this. So in order to improve the UX, user experience, we started collecting real-time data. Click streams. What is being clicked? How many times we are going through the pages and going to our target on the web store, what it takes me to find the product and finally buy it. I want to do that faster for the user, so the user is not getting annoyed and not jumping to another website. And slowly, we are going to the real-time analytics. I want not just provide the better user experience from the website perspective, but I also want to do things like updating the real stats, like how many items I have in stock. Is it still possible to buy? But even more, if we are going actually into the another use cases, we can track almost anything. Any sensors that we can attach to the devices, anything that we can send the data from to analyze the data and do. The most valuable data is the data that can tell me what will happen in the future. And for that, I need the data now. I need to process the data. I need to analyze and make decisions. One of the use cases that I was thinking about this, what kind of examples I can provide here. And after a year being in COVID and we were all grounded, my kid had the triathlon in Florida, and I had to travel to Sarasota. It was last year in February, and I'm coming already in Florida to the gas station, and I tried to pay with my credit card, and it got declined, rejected. And I got immediately the notification on my phone that your payment, your transaction got rejected because, not because. I called them and asked, like, what's happening? Like, don't worry, you're good, everything's all right. People were not traveling, so our system detects like you were a year in one place and now you're paying in Florida. For our system, it sounds strange. But this is the exceptional use case, right? We are trying to catch, really analyze the data and try to prevent the fraud. We are trying to do the anomaly detection, and not only in the financial sphere, right? We are trying to do the anomaly detection with the sensors, on the manufacturer, for example, on the line. We want to predict when the engine will break, when the car will stop, when the website will provide you incorrect data. And that improves our experience, as the users of the systems, as the manufacturer, as the owners of the business. And another use cases are related also to the IoT, right? We all have already smart switches. All this data is being streamed. You want to open your phone. You want to see the status of your locked door, if it is locked or not locked. Maybe you have kids home and you want to see that. You want to get notifications that somebody is at your front door. Amazon delivered the package. There you go. I have a notification from my video camera, right? From my doorbell. Real-time personalization. We want to go to the online store, and if I search for the information about a Ferrari, and I go to the tire store, a simple example, I want to see the tires for my Ferrari, and not for Jeep. I'm actually a Jeep owner, so I better to find for Jeep. But the real-time personalization sometimes getting annoyed, right? We are searching something for on a Google, and after that, for the months, we are getting the ads in Facebook. Wow. But it helps. Sometimes, if the more we use, the more we do the personalization, it actually gives better results. So even in my Facebook, I'm scrolling, and it's more or less in my interest. So it's better than get something annoying that I'm not interested at all. But when we are talking about the more serious use cases, healthcare. I have a friend that sometimes we watch late night TV, play poker games between friends, and he's getting notification because 2 of his kids, they having diabetes. And during the night, the sugar is jumping high, dropping low. He's getting notification, he's picking his phone, calling his kid, go take a pill or take a candy, and do something with that. And this way improve the experience actually working with your kid instead of waiting until that kid will suffer from the sugar or oxygen. There are devices that are measuring oxygen, right? There are devices that are measuring your heart rate. They are always on you, right? So it's important use cases in the healthcare. They can save even lives sometimes. All these use cases, all the streaming is actually the same pattern, right? You have a source, you have a device, you have the data provider, whether it is the web page, it is the switch, outlet, car, locomotive, airplane, wherever. It's a data source, and you need to ingest the data source. And usually we're talking about the integration and about the different adapters or the producers of the data, right? So all the data is going from the device to the storage, and this storage is it can be real time it can be in the memory. It can be on the physical device, like SSD, HDD, or whatever, depending on the price that you want to pay for that, right? Depending on the performance that you want to gain. And after that, you have processing. And the processing can be windowed. You can analyze the data over, like, for the last second, if it is important to you. You can analyze the data for the last year. If you have enough memory in that application, bless you. In that to collect the data and aggregate the data, right? So the data processing can be different. It can be real-time, low latency. It can accommodate the high throughput, and we will talk about that. After that, you process the data, and you are sending the data to the destination, to your output. And it can be a data lake, it can be a data warehouse, but it can be another device that will take the data and do something with that real time, like your notification, like the another device that will make changes in the configuration, et cetera, et cetera. This is how we create our DevOps pipelines, right? The dashboards, we are getting this real-time information from different systems, from different applications, and we are monitoring them. Yeah, it's hard to set it up, right? It's before we were talking about, like, give me the technology. I am giving you technology. This is your engine, this is your device, this is the integration. You're all good, and this is your solution. But how to build it? To build a solution, usually it's a tricky thing, right? You need the architect. You need somebody that will bring you all the pieces together, and I'll tell what you need to do. But when you start doing that, you need servers, you need the software, you need to integrate everything, and after that, you build it. Finally, for your POC, for your first POC, and you're like, I'm good. My thing is working. Now I'm going into production. Well, before that, obviously, you will be running low testing performance, but you are going into production and you're expecting 1,000th time load of your POC, of your simple programs that you develop for a single device. Now you have thousands of devices. You have thousands of consumers for that data, and you are trying actually to scale, right? And here we go. We are scaling, and there is a problem. We don't have servers. We don't know how to add. If we add new servers, how to configure that properly, et cetera, et cetera. We need to integrate. We need to write the software for the integration, and sometimes you even need actually to take care of the production issues and fix your hardware, your software, your fallen brokers, something is not working. So we are looking for the services that will help us to do that, that will manage our pipelines, that will manage our streaming, our processing, and will stream provide as much automation as possible. Kinesis, Amazon Kinesis is not a new service. It's an old service already in AWS, known service for many things, how to bring the data from one place and store it in another place. Okay, and in Kinesis family, we have Kinesis data stream, which has a retention policy, right, predefined. You can store the data for 24 hours. You can increase it to 7 hours. And now we actually, 7 days, I apologize. And now for the long term, we provide the new features that you can store it even up to a year. Kinesis data streams is easy to set up. You just go into your AWS console, or you're using your CI/CD pipeline, and it's like click, 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 and you got your stream. All you need to know is actually how to provide and how many shards you need to provide, right? It's a scalable on the shard level. You want more input, you want to provide more output, you want to provide the throughput, you just increase the shards or decrease them. You can actually scale out and scale in. And once you do that, you have your data coming in, but what to do with the data that is coming out? In many cases, you would like actually to deliver the data into the standard outputs, standard targets. S3, OpenSearch, Redshift, you can read it. So it's in most cases, you don't want to start deploying your software, your connectors just to store the data. So data firehose is the things that actually can push your data without any code into the final destination as it is coming and performing some basic transformations on the fly. Kinesis Data Analytics is the framework to manage your Apache Flink workloads. If you have real-time streaming analytics and it's run and you are using Apache Flink, you can use Apache Flink. It's a framework, developer framework based on the Scala and the Java APIs. You can develop in both languages and you can deploy, and all you need to worry about is how to implement your streaming logic, how to implement what you want to achieve. You don't need to worry about the infrastructure behind that. It can automatically scale. It can support sub-second latency as the regular Apache Flink application, and you only pay when you use it. If you don't use it, you stop the application and you don't pay for it. We provide all the time new features. We provide the new automation on how to do that better, faster. We improve the default settings for your application. We add the automatic, we just recently added the automatic scale to the applications. And this piece, if you need more than just standard destination, like with the Amazon Firehose, you can use the data analytics, Kinesis data analytics, in order to do more. This is my favorite. I'm actually leading Amazon MSK for professional services and the Amazon Managed Streaming for Apache Kafka. This is another framework for the streaming data, and it's fully managed Apache Kafka solution for the implementation in the large scale, small scale, any kind of scale scenarios. In Kafka, you have producers, you have consumers, and you have the infrastructure for the Kafka itself. You have brokers, zookeeper, configuration, etc. And we handle all of that as part of the Amazon MSK. So highly scalable. It provides you the handling for the replacing the brokers when they are falling, when they are actually needs to be replaced. Like EC2 instance can be replaced. We run agents that will be doing that for you. And when we are in a problem, we have issues with EBS volumes. We have issues with the hardware. It's all managed. All you see, your cluster is going to maintenance, coming back from maintenance, and you are getting the cluster back working. You don't need to worry about that. Once we started actually providing the Apache Kafka, managed Apache Kafka, we said, OK, what's next? We need now another framework that is coming with Apache Kafka is Apache Kafka Connect. And we created Amazon MSK Connect, which is actually managed Kafka Connect. We can deploy the connectors. We can standardize the approach, and we will scale it the same way as the other applications. It's a scalable solution, and will provide a lot of flexibility on deploying your standard or custom connectors. Now, with all that is coming the metadata, right? The data is beautiful. I have it here, right? The data is beautiful. But show me your data, how beautiful it is. And we are talking about the schemas. I want now to manage my data. I want to prevent, during the streaming, I want to prevent my application from falling, from breaking, just because one of the producers, one of the data providers changed the schema, right? So we are talking about the data evolution, schema evolution, and how it is supported in the schema registry. And that provides a lot of security, a lot of peace of mind of the consumer application when they will be consuming, of what kind of data they should expect. And if the data is not as expected, consumers will know actually how to handle it. But producers and consumers can provide and can evolve differently depending on the compatibilities that you can provide, as that you want to achieve. If you want to do the full compatibility all the ways, you are defining on the schema registry your desired compatibility mode, and it will ensure that all new schemas that will be created in the schema registry will be compatible with that. And at this point, so we are talking about these services, and do you have any questions about them?
It's a little bit longer question. Since we have moved on to the data analysis, I'm going to go back to where you started with big data, right?
Easy.
So, my understanding is that most enterprises are a little bit mature in getting data, and they get it through batch, and that pipeline of data and data analysis is there. And enterprises like us, we are struggling with the latency there, and we want to move to near real-time data, and that's where streaming comes in. And I know you presented two architectures. One was with Kinesis, and one was with Kafka. And I want to dwell a little bit more in there, because today, if you want to get near real-time data, right, you want to inject something into your transactional processing and get the data out real-time. But we don't want latency there, right? Because we are trying to inject something into your real-time processing, and I saw that there was a 200 millisecond processing if you take that back. So what I was wondering is that if you want less intrusion, you go to the Kafka model where there's less intrusion of real-time transactions to get the data out. So I want to dwell on those two comparison of those two architectures you presented or solutions you presented, and guidance. Which one would be better if you want transactional data coming near real-time for analysis of the back?
Thank you. So let me summarize the question. The question is, we have the enterprise that is very comfortable to process data in batch. But when it's coming to the streaming data, what should I use? The biggest question, and this is one of my usual questions from my customers as part of the consultant, part of the professional services. I'm getting this question all the time, like, so what technology I should use? Should I use the Kinesis, or should I use the Kafka? And the answer for that is, it depends. Kinesis is, we are saying Kinesis, low latency data streaming engine, right? And Kafka is low latency. But how low that latency is? Both of them can accommodate any kind of throughput. The throughput can be huge, right? We are talking about like from kilobytes, which is a tiny, tiny, tiny throughput, to the gigabytes, to hundreds of gigabytes a second. And I'm very confident that any of these services can handle such. But the latency is the Amazon Kinesis is, let me go back. In average, we are seeing the latency on the Kinesis data streams around 200 milliseconds end to end from the producer to consumer. Okay, so do you consider it fast or do you consider it slow? Now, and it's your use cases, right? For some use cases, you want more flexibility. You want lower latency. I will tell you, I have customers that are actually fighting for the 20 milliseconds turnaround from the producer to consumer, and the Kinesis cannot satisfy that requirements. I would go to MSK. I would go to the managed Apache Kafka. It's faster, a little bit. Not always you need that speed. On the other hand, Kinesis is much simpler service. All you need to do is define your shards, right? The number of shards is the stream. Think like a stream is the Kafka topic. All you need to provide the shards. You don't think about the infrastructure. With MSK, you have to provide the number of brokers. You need to select the type of the broker. You want to do the configuration on the broker level. You want to configure and you want to tune the operational system level, right? The request size, the socket size, how much memory you allocate to this and that. You don't need to think about that with Kinesis data streams. It's all yours. Like, just here, the API, just use me and that's it. But there is the limitation. Not always there is the solution. This also comes with the limitation. So always the trade-offs. That's why I'm saying, like, it depends. If you want to go really low latency, you have to choose the Kafka. If you want to go with less hassle, and you are fine with the latency, with 200 milliseconds is, by the way, it's a pretty good latency still. It's under second. Do you remember 10 years ago we were talking about under second? It's a fifth of a second. Yeah, enterprise, your batch request and batch data a days, a month, and here we are talking about under a second processing. In many cases, that will actually be sufficient to provide the response for your request. Does that make sense?
Yes, thank you. Sorry, I just want to follow up on a point there. One thing I would like you to comment on is the region replication of Kinesis data versus Kafka. So one of the things we've looked at is, we've talked to some AWS reps about this. Like, if you have a catastrophic failure in a region and Kinesis is in there, what do you do, right? Like Kafka, there are tools you can figure out how to get data to and from different regions and think about that. That might be one thing that turns your head, but I wanted to see, if there's a roadmap or how you think about
that. I get what you're trying to understand, right? Like, which service is better for the cross region? Or what it is?
The benefit from the complexity.
So, first things that I would start looking into is the two black boxes, and if you can achieve the cross-region replication with the custom solution. And with the custom solution, you can achieve with both of them. You can have the streams, and you can have Kafka replicated to another region. Right? You may run the Kinesis data analytics, Flink's application to replicate the data. You can actually do that asynchronously and the batch way. Actually, your RTO will be higher on the disaster recovery and failover. You may lose the data on another region, right? A longer set of more data. But it depends on solutions that you want to build and how important that delta that you will be losing is. In both cases, there is a solution for that to replicate the data and this custom solution, right? We are not talking at this point, we don't have the cross-region managed replication. And there is something that you can build using managed services, but there is the custom solutions that you can achieve. Now, what I like in the Kafka better is the offset translation. So if I switch from one place to another place, from one region to another region, from one account to another account, I can manage, I can pick up from the place that I left on my another cluster, on my previous place, right? So Apache Kafka is coming with a mirror maker. It's a mirror maker 2 is an amazing tool. It helps actually to provide the solution for disaster recovery. And it will help you to translate the offset, and the consumer groups will be translated on another cluster, so they will be able to pick it up from there. There are some attempts right now with the custom solutions actually to achieve more or less the same with the data streams, and we can talk about that, like how to build that proper replication, but the data can be replicated. The data can be replicated using Lambda, using Flink, using S3, and just sending the data and processing the data. That can be done. If you ask me what is easier to do, for me, easier to set up the mirror maker on MSK Connect, both managed services, and do that. The question if the Kafka is the right solution for you for your bigger problem, not for the replication, for the problem. But that could be a part of the consideration of on the selecting the service. Say it again.
The cost implications of these two architectures.
Cost implications? Understood the question. The question is, what is the cost implication in both these scenarios? Like, which is more cost effective? I don't think that the cost will be the biggest problem for the disaster recovery. When we are talking about disaster recovery, we want to avoid costs that we can lose in case of disaster. In case of disaster, you stop your business. In case of disaster, you cannot serve your customer. You are getting frustration from your users. This is the cost that you are spending. Now, if we just compare the cost, actually, what is the better? I don't think the cost is the data that you are moving from region to region. The amount of data that you will be moving in both cases will be the same, right? Only the cost difference, if I understand correctly, the question that you're asking will be behind the engine that will be processing that replication. And here, it depends. You can replicate cluster to cluster with Kafka using the Apache Flink, right? And the KDA, and you will have actually the same cost. The same amount of data will be transferred for that. So I don't have a really good experience to compare because my customer never talking about like comparing the cost. Like comparing two services more about the comparing the APIs and capabilities than the cost for just replication. Yeah?
So I have a question here. So in terms of the latency, I just want to bring it up from the network layer and from the app layer. You have the 200 millisecond. I understand that's how much of that would be within the Amazon environment, and how much of it would be actually in the transport post-Amazon environment to the end user? Or is that just within Amazon?
So the question is 200 milliseconds, what it includes, what it is. If it is the only inside the Amazon within the infrastructure, or it is end-to-end latency for the user. So 200 milliseconds, we are talking about from producer to consumer, including the network, including the replication, ensuring the high availability, ensuring the data is being delivered to the consumer and accepted by consumer.
So does Amazon have any analytics? Some coming from a carrier network standpoint. How can we lower that down and do an Amazon interconnect? How we're going to optimize our last mile, middle mile, all that network, and lower that because we're looking at the application that comes out. You need that sub 100 millisecond. How can we reduce that?
Understood. Majority of the time of these 200 milliseconds or with the Apache Kafka will be spent actually on the infrastructure. In Kinesis, in MSK, to replicate the data, ensure the high availability. When we are talking about, for example, producers, we have producers up to 5 milliseconds to produce the data and get acknowledgement from the broker. in MSK. This will be a little bit, maybe a little bit longer for the Kinesis data streams because of the way the API is working. But this, again, we are coming to the API itself and not to the network. So the network right now is not a bottleneck for us. At least we do not see. In most cases, we have the direct connect, right? We have everything in cloud. So the network, I don't have the experience of having issues on the network layer that would impact the latency of the entire solution end to end.
I have a unrelated question. In case of Kafka, we know that we have a use case of data replay. So, like if we have to access historical data in the stream, like going back, say, a few minutes. So in Kafka, we could do something with offsets. Like we can play around with offsets and then try to get back the data, and then again continue with the streaming. So is that something available in Kinesis?
It's the same. So I will repeat the question. In Kafka, we have offset management that is consumer offsets that we can store, and we can retrieve that offset from the Kafka itself, right? In the modern Kafka, and what's happening with the with Kinesis. So Kinesis clients and consumers. Same way when they're consuming the messages from the streams, from the shards, they have the offsets from there as well. And you can actually manage them on your own. You can set it when you are defining the consumer from the Kinesis shard. You can set the offset same way as in Kafka. So you can manage the same way. It's very similar. Yeah.
I have a use case where I need to compare two different files and generate the output and publish to the Kafka. So which one is better, AWS Glue versus Apache Flink? I'm not sure what is that Apache Flink.
The first one, what was that?
I have two different files, CSV files, compare and stream it to Kafka.
Right.
Yeah. So which one is better, AWS Glue versus Apache Flink?
AWS?
Glue.
Glue. Oh, I apologize. The question is, we have two files. What is better for the processing? Glue to ingest into Kafka? Is it a Glue or is it Apache Flink? They are different actually entities, right? They are different engines. Glue is more batch oriented, is more ETL oriented, even though there is Glue streaming, which is kind of managed Apache Spark. But Glue, by the nature, is more batch oriented. It has its own integrations with other services. While Apache Flink has its own set of features. So it depends on your workload, what exactly you want to do. Oftentimes it comes to the price. Okay, so Glue, depending, and it's hard actually to say what will be a higher price, Glue or KDA, Kinesis Data Analytics. It very depends on the workload itself. So sometimes we have a comparison running like load test and to understand the better processing engine. Oftentimes you are depending on the libraries. Apache Flink has its own analytical libraries. It's a lower latency, like it's not micro-batching like Spark. It's working on the real-time streaming. Apache Spark is like micro-batching. So when we are talking about reading from the data files, the KDA will not be the answer for you because it's not, unless you are streaming these files on your system. KDA, it's a streaming, Apache Flink streaming application. You need to have a streaming context. It's not a batch application. So if your files are batch data that you are loading, you probably want to go with Glue. If that is the files that you want to stream from your system and expect new and you have a connector from that, like S3 connector or source connector, S3 source connector, or you have the file system, etc. You can go with the Flink, but oftentimes you will find yourself that you will have specific libraries that you want to use, and they will be coming from the or even specific people and skill set. That is Spark, that is Flink, and it depends on the environment as well.
I know we have a lot of solutions built out during our batching for errors, make sure we regrab messages as necessary. How does that handle in a data stream for the ingestion in case there's any kind of errors, outages, et cetera, to make sure you're capturing all the data and have proper redundancy?
Can you give me an example, please?
Sure. If Kinesis goes down for a little bit, for some reason, we've lost that amount of data, that 5 minutes worth where there was an error when it was trying to ingest. How do we make sure that we're capturing that, going back and capturing those messages?
Okay, so the question is, we have a producer that is actually wants to produce the data, and in case of Kinesis, how it works actually for the producer if Kinesis is having or experiencing some outage, how it will be working, how we can build a solution around that.
Or Kafka or general, just data streaming in general, how we handle that versus.
Exactly. So that's what I wanted to say. Kinesis, data streams, and Kafka are not different in from this perspective, right? Both need actually to give you the acknowledgement for your producer that they receive the data. So in Kafka, you control the type of acknowledgement. You can say, I don't care about the acknowledgement. Just get my data and do whatever. I don't care. In Kinesis data streams, you are sending the data, you are getting acknowledgments. That means the data is stored for sure. Same as acknowledgement all for the Kafka, right? So you need to implement your producer. You need to create a buffer sufficient to handle your possible outage if you want to ensure the 100% data delivery. Now, within this buffer, you can do the failover to another region. So disaster recovery solution can help you actually to address that. And by rebuilding or actually creating your producer fault tolerant, you can actually fail over to a new environment and produce all your buffer actually there, and they continue streaming in the regular mode. Does that answer the question? Yeah, good. More questions? Yeah.
So we've got a pretty specific use case on the healthcare side. We're streaming data from all bedside monitors across 11 hospitals into AWS, running a few predictive models, and then getting that information back to the providers to do things like predict cardiac events or septic shock or things there in the hospital. Outside of latency, like we are doing a POC right now with Kinesis data streams and data firehose. Is there another thing that we're missing out on by not going to Kafka instead?
I like Kafka, right?
Yeah.
There is nothing wrong to do the Kinesis. Again, I like Kinesis in very particular ways. I like Kinesis even more. It's easier. You don't need to worry about your infrastructure. In most cases, Kinesis provides you easement. It's easy to use. Like you have an API you produce, you have a lot of tools that integrated with Kinesis. And with the recent feature, with the auto scale for the Kinesis streams, you don't even need to think about provisioning a lot more shards. It will do that for you, right? So I do not have a problem with that. If you do not have a problem with the low latency, like this is low enough, it's all yours. And I like this managed way of defining the Kinesis data streams as the source for the data firehose, right? It's all managed. You don't need to do anything. Like you are clicking, I have my stream, I have my firehose, and I have my S3, I have my Elasticsearch or whatever it is, right? The open search engine, Redshift, or whatever delivery I want to do. So I absolutely hear with you. The other considerations that could be there, probably not to you because you did not mention that as your problem with your use case, but with the multiple consumers. Kafka, the shard is scaled, as you can see. Can you see that properly? The shard can scale on 1 megabytes per second input and 2 megabytes per second output. So it's actually 1 to 2. If you want to achieve a reading speed over 2 megabytes per second, you already need more shards, right? Kafka is a little bit more flexible on this from this perspective. It actually limited by the infrastructures that you are providing and not hard limited, except for the, I forgot to mention, and I am super excited as I'm Kafka. We have serverless. We have now Kafka serverless, MSK serverless. Now you don't need actually to provide the number of brokers, type of brokers, etc. All you need to do is to say, tell me how many partitions you want actually for your topic to create, and I will manage the rest. I will do the rebalancing of partitions. I will do everything that you were supposed to think about in terms of the scale. The horizontal scale in Kafka is disaster, right? Like you just think about adding new broker and it will be empty standing there until you rebalance all your partitions. But just to rebalance, it takes a lot of time. You need to find the time out of your peak hours because it will increase the internal traffic. It will copy the data from broker to broker just to satisfy like the proper distribution of the load. And this rebalancing is tricky, oftentimes. There are tools that can help you, right? The cruise control and the different things. So, but still, you need to think about that. With the serverless, you don't need even to think about that. Just here we go. You have my cluster. I want to create this topic, this number of partitions. That's it. Then you will be limited with the input and output as well, per partition. So you will need to actually scale and think about how many partitions you need in order to satisfy all the output streams, all the input streams, etc. Yeah?
Last time I looked at Kinesis, there was a limit at how many scaling operations you could do in the shard within some period of time. I forget what it was, how many you could do within a 24-hour period. A, does that still exist? B, does MSK serverless have anything that's kind of along those lines where you shouldn't ram partitions up 400-fold and back down 200-fold?
Okay, so a catch with Kafka. At least with the Kafka, with the serverless, you cannot scale down the number of partitions. So once you scaled up the number of partitions you are there, I think that we are working on that. This natural ask to be able actually to scale it down, right? With Kinesis, yes, there is the cooldown period, and the same with storage, for example, right? For the Kafka, you need to provide how much storage you want to allocate for your broker. If you want to increase the storage, there is the simple API, right? You don't need actually to go and grab the disk and connect to your broker, and and before that you need to order and wait, right? So it's not you just the API call or just click on the console. You increase your storage, and you have 6 hours cooldown period with Kafka as well. But during these 6 hours, you continue working. It's not like you are in the maintenance that your cluster is not accessible, but you will not be able to perform any other storage operation.
Sorry, clarity on the cooldown period. You're saying you can't scale up or scale down within a 6-hour window after you make some kind of modification?
For MSK, you cannot scale up. Scale down, you cannot do anytime. Scale down for the storage, you can just increase the storage. You cannot decrease the storage at this point.
And what was that for Kinesis?
For the Kinesis, I don't remember the cooldown period and the how much time you need to wait to be guaranteed that the scale down will be complete. I can double check. We can take it offline, and after that I will check. I just don't remember out of my head.
Last time I looked, it was like you could do 2 operations in a 24-hour window or something like that.
All right. Any other questions? Yeah.
So
want to allow external vendors to hook into those events to trigger their own workflows. But based on the sounds of that, it sounds like it's not really meant to have dozens, hundreds of consumers. Is that correct?
In Kinesis,
Correct. Or in Kafka. You mentioned both really have limits on how long, how many before the event on too.
well, both have limitations, right? I mean, any technology has a limitation, right? You need to connect, and that connection will take some time, and you will be limited by the amount of memory. You will be limited by amount of resources that you can satisfy. They are different just for Kinesis and for MSK. For Kinesis, you can have I don't know the actual limit, to be honest, of the number of consumers. All you need to do is to scale appropriately the number of shards. So you have the number of connections and you have the amount of data that you can stream it out, right? But once you're there, you are satisfying the number of shards to satisfy your workload, you will be fine. What you will experience if you do not do that, you will experience the throttling. And you will have the exception, coming like throttling exception, that your consumer will need actually to wait a little bit until the next request and pull new amount of data. All right. To sum up, streaming analytics is a cool thing for now. For now, right? It's a data is beautiful, especially when it is available in different formats, right? Batch data, real-time data, analyzed data, raw data, secured, PII, SPI, personal identification data, the identifiable data. In all these cases, these services provide you a secured way to access it, to store it, and to share it. You can control the access, you can control the encryption. If you want the highest level of encryption, you encrypt the storage, you encrypt the in-transit, you provide the access policies based on the IAM or based on the username, password, credentials, etc., etc. There are different techniques actually to provide the authentication and authorization to your data. But in all these cases, it's pretty much secured and safe for production workload. And most important, it's managed. So if there are no other questions, thank you so much. And again, welcome to Summit and welcome out of your houses.